Hey guys, I'm just going to talk you through question W31.5 in the workbook. It's page 100. So it says here in the question, a scientist tested two spiral springs to find out if they obeyed Hooke's law. She placed different weights at the end of each spring and noted the extension. Her results are shown in table W31.1. So you can see here in the table, there's two different springs. So you have spring A and spring B. Spring A, when a force of 1 Newton was applied, it extended 6 centimeters. With 2 Newtons, it went to 12 centimeters, 3 Newtons, 18, 4 Newtons, 24, 5 Newtons, 30, and then 6 Newtons, 36. You can see from that every time 1 more Newton was added, it increased by 6 centimeters. Spring B then was a slightly stronger spring. So when we look at it, when a force of 1 Newton was applied to B, it extended by 5 centimeters. Then we have 10, 15, 20, 22, 24. Okay, so it was a stronger spring overall. It says here in the question, plot the data from spring A on the blank graph in figure W31.2, join the points using a ruler. We haven't done much on drawing graphs, so that's why I'm drawing out this question for you. First thing that I'm going to do here is I'm just going to draw in my axes. So I take my pencil and my ruler, nice straight line. Do not draw these without a ruler. Do not draw these in pen. So they're pencil and ruler. So I've drawn in my two axes there. Now it says I have to plot the data from spring A on the blank graph. So this is our actual data for A. So it's the first one here that we're looking at. And on the graph, it looks at the force that we're applying and then the extension. So I'm just going to fill in my axis here for spring A first of all. So the force is going on the bottom here. So I have force. I'm just going to go starting off with 0. Then I have 1, 2, 3, 4, 5, and 6 newtons. Okay, so I have all that filled in there. In the extension has to go up to a maximum extension of 36. So I have to try find something that's going to fit in here nicely to actually fit 36 in. I can't just go up one box at a time because that means that I wouldn't have enough room. So instead what I'm going to do is I'm going to go up in 5s. So you have to work out what works well. So I have 5, 10, 15, 20, 25, 30, 35, and the last one then is 40. Now you'll notice here that I went up and each big box here is equal to 5. All the boxes that I used are the same size. I can't go up 5 for the first one and then have a big gap then and then have this one here is 10. You must keep it in order. Okay, so the next thing that I do is I'm trying to actually plot the points here. So the first point we have is with a force of 1 Newton, which is here, the spring extended 6 centimeters. So I come down to where I have 1 Newton on my graph, which is here, and it went 6 centimeters. So I'm going up into this box and it's 6 centimeters. So I put in a dot, put a little circle around it. The second one then, it says 2 newtons. We're going a distance of 12 centimeters. So 2 newtons, and I come up here as far as where 12 is. Draw my circle around it. Third one then, so 3 newtons, and it's going up as far as 18, which will be just about here. Draw my dot, circle around it. Fourth one is 24. So up from where 4 is, 24 is here. Up from 5, so it's 30 newtons this time. So we're going all the way up as far as here. So up from 5 and then 30 newtons. And then the last one is 36, so up from 6. And then I have 36, which is here. Now I've drawn in all the dots. It does say here to join them using a ruler. So I'll do that. So any dots that I've added in, I'll join them up here. So one straight line. What the question says then, it says, what is the shape of line A? And this is line A. This is the one we're after drawing here. So I'm just going to label it as A. So what is the shape of line A? The answer is it's a straight line. It says then for part B of that question, does spring A obey Hooke's law? And the answer here is yes. Because Hooke's law states that the extension of the spring is proportional to the force applied. And in this case here, it's going up 6 centimeters at a time. So as you increase the force, yes, it is proportional. What evidence do you have to support your answer? The answer is it's a straight line. Okay, now the second thing we have to do here, it says plot the data from spring B on the same graph. where possible, join the dots with a ruler. Okay, so spring B we're looking at this time, and we just do it exactly the same way. So spring B is this one here. We have, first of all, a force of 1 Newton, and it moves 5 centimeters. So 1 Newton, we have 5 centimeters, so I draw in my dot. 2 Newtons, it goes to 10 centimeters. So again, up from 2, wherever 10 is, draw in my dot. At 3, we have 15 centimeters. So up from 3, where 15 is, put in my dot, circle around it. 4, then we have an extension of 20. So up from 4 and then 20 centimeters. We then have 5, which is 22. And then the last one then is 6, which is 24, which is going to be just here like this. Now, that's all our dots drawn into the graph. It says here, where possible, join the dots with a ruler. So I can only join some of the dots with a ruler. I can't join all of them because it doesn't quite go in a straight line. So it starts like that and then it kind of curves off. So I can finish it off here just freehand. This is for line B. Okay, so I'll label that as B. It says in the question, what is the shape of line B? And the answer here is that line B is going to be a curve. It then says, does curve B obey Hooke's law? And the answer here is no. What evidence is there? The answer is it's not a straight line. And then finally, part 1 of H here, it says, or part I, it is, sorry, suggest a reason why a spiral spring might not obey Hooke's law. And the reason for that is it may be overstretched. Okay, so this is just a quick introduction here to drawing graphs as well. Thinking about it here, the first thing that I done was I drew in my axes. The next thing I done was I labeled them. Then I done what's called my scale. So drawing the axis was just drawing the lines. Labeling them was already done for me, so the extension and the force. The scale is me splitting up where the actual axis is and putting in the numbers. The fourth thing I done is I put in my points, and then the last one is join the dots. Okay, and that's all we're looking at in this question. If you don't get this question 100% correct, I'll know you didn't watch the video. Hope you enjoyed it. Talk to you soon.